Good day, everyone. It's a real honor to be here at PostGIS Day, and I'm here today to talk about a shared challenge: the divide between our operational systems and our analytical systems. My name is Fawad Qureshi, and I'm a global field CTO at Snowflake. This talk isn't about or, the keyword is and. It's about how the amazing open source world of PostGIS and the scalable world of the AI data cloud can come together to break down barriers. Today, as we know, PostGIS powers application and data warehouses power analytics. And for decades, they have lived in separate worlds. We all know this divide. On one side, we have our systems of engagement, and for the geospatial, the undisputed king is PostGIS. It is fast, it has the richest functional library on the planet, and it's the open source heart of countless applications. On the other side, we have our systems of insight. This is where we try to analyze massive scale data, and historically, this is where things get difficult. The traditional data warehouses that our companies use often have weak or no GIS support, can't scale, and force us to create another data silo. And in the world of analytics, this silo creates a lot of challenges. GIS, or the GPS technology more specifically, was created back in the 60s as a classified technology. And that legacy of being a classified technology for a long time has remained in our data ecosystem. We Every customer, every industry that I talk to has an enterprise data team, data analytics team, and every customer, every industry has an enterprise GIS team, and they hate each other. They don't talk to each other, they don't interface with each other because they all have different types of systems that have their own strengths and weaknesses. And I'll talk about some of the examples and stories that I have worked with. So, at the beginning of COVID, I was working with a telco to build a COVID contact tracing system. We built this on 3 months of data, lots of several terabytes of data combining with healthcare data, and we built a model, and it was fairly accurate. When we tried to move that model to production, the DB of the data warehouse said, Fawad, if your query takes more than 3% CPU, I'll kill the query because I cannot afford for your complex geospatial query to create resource contention issues with the rest of the workloads. So we had to take that workload out of that central warehouse and run it into a separate system. Whereas on the other hand side, in the world of GIS, well, I was using a very popular desktop GIS tool trying to connect it to Snowflake, and it gave me an error. I'll not connect to a table with more than 250,000 rows because most of the desktop GIS tools, they try to bring in all the data into the laptop memory and they try to process it them there. So scale becomes a challenge. And then when you want to do complex advanced geoprocessing, again working with a retailer here in the UK, they asked me to help them with identifying their loyal customer. Upon inquiring the definition of loyalty, they said they live close to the number one retailer in the UK and they drive past that retailer to shop at their store. They are a loyal customer. So literally going the extra mile and not shopping just because of convenience. So we had to do drive time calculations, but most of the databases only support crow flies distances, and crow flies distances are useless when it comes to urban cities. So we had to export the data out of that data warehouse into a separate routing engine, and it took several weeks for us to complete the job for like 10 million customers. And then if you want to combine various type of capabilities in a traditional GIS tool, it becomes a very cumbersome task. So how can we build a world where we are able to combine the capabilities of all of these operational and analytical enterprise data systems and enterprise GIS needs all in a single platform, in a single solution where we don't have to make a decision, we don't have to compromise, we don't have to say, oh, this or that. How many times can we add an and to the conversation? That's the vision that we are trying to work towards. So, why is a company like Snowflake here at PostGIS Day? It's simple. We are heavily invested in the open source world and we believe in using the right tool for the right job. PostGIS is the right tool for transactional geospatial, and our goal isn't to change that. Our goal is to solve the other side of the problem, the analytics silo. In fact, our commitment to this ecosystem is growing. We're investing heavily in Postgres, including our new fully managed Snowflake Postgres offering. We are part of this community. So, for those of you who aren't familiar, here is a quick intro to Snowflake. It's not a traditional database like Postgres. Its core architecture is different. It's a cloud native solution. It separates storage from compute, allows you to run massively parallel compute on a very large amount of data. This means you can have one copy of your data and spin up or down any number of compute engines to work on it, all at the same time, without them ever competing for resources. You can run various type of workloads on the same type of data engineering, data lakes, application, geospatial, advanced warehouse, all of that on the single copy of the data. This is why it is so powerful for these advanced types of analytics. You can run a massive GIS query, a BI dashboard, and an AI model at the same time, and they won't slow each other down. It is built to solve the OLAP side of that great divide. SQL is powerful, but most of our stakeholders don't read SQL or GeoJSONs. They want to see a map or a dashboard. This is where another open source tool, Streamlit, comes in. Streamlit lets you build a web app purely in Python in just a few lines of code. And Streamlit is available natively in Snowflake. This is a game changer for JS analysts. You can write a Python script that queries your PostGIS and Snowflake databases, does some analysis, and then instead of just printing a table, you can display an interactive map that a manager can actually use. It's another way to bridge that gap between the technical expert and a business user, building on the open source tools we all know. And the same application can be shared with desktop tools, with mobile devices, tablets, and more without the need for installing any client side utilities. There are no copies of the data being made. The application runs directly on the data, following the same underlying data governance principles that were set up when data exchange was set up. And that means there you can trust the process. You can create lineage traceability across the entire process, and it is very simple, easy to use, and extremely simple to deploy. So this brings us to the state of the art today. This isn't hype for 2026. This is what you can do right now. The best part is you can use the open source tools you already love, like QGIS or modern web platforms like Felt and Carto. These tools can connect to PostGIS for your live, hot data and to Snowflake for your massive cold analytical data at the same time. Imagine on one map seeing your live field crew locations from PostGIS layered on top of a 10 billion row heat map of customer activity from Snowflake. That's the power of this better together approach. Now, for a little fun. We all know PostGIS SQL is incredibly powerful, but how many people can remember std within or st intersect, which isn't something your average business user knows? I know we have a lot of geeks and a lot of technical people in the PostGIS day today. But if we look at the global statistics, I was looking at some stats from Statista. Across the whole world, there are only about 4 million GIS developers. We have 18 million Python developers. We have about 85 million SQL developers. But do you know how many English speakers are there in the world? Including the people who are native speakers as well as second language speakers, it's nearly 1.46 billion. And the world population is 8.5 billion. So why I'm talking about these billions of numbers? Because we now have an ability to build natural language interfaces on top of this data. What if we could use AI to build a bridge for them? We can experiment with using Snowflake's AI service, Cortex, as a natural language interface to PostGIS. We can build a translator, a middleware that can take those natural language questions, convert them to code. And the beauty of this is Cortex allows you to bring any type of AI model, any type of LLM, open source, commercial, private. You can host your own models, and we ensure that the data remains private, your metadata remains private, your model remains private, and your prompts remain private. We'll guarantee that your data will not be used to train somebody else's model. The user can then ask a question in plain English. Cortex generates the complex PostGIS compatible SQL, and you could execute this query against your PostGIS database or even against the new Snowflake Postgres service and get back the GeoJSON to instantly build a map. This is about accessibility and reaching out to domain users that were not able to access the data before. So you can have defining conversations. You can have bi-directional conversations. So people can ask questions in English to map, and you can ask the build describing interfaces. Oh, I have this map. I don't understand what it is showing me. So you can take a screenshot of the map, or you can ask for more metadata to describe what's happening inside the map. So instead of people raising a ticket to IT teams, the end users can interact with the data using self-service, ask the data, hey, give me more context, give me what's happening, so that you can build more powerful, more empowered users inside and outside your organization. So one of the things that we are seeing in the world is this move towards open data format. I was working with a major public sector agency, and they are what they told me that they have like 2.5 exabytes of data across various of their data estates, but the unique data is only about 300 petabytes, copied 8 times over into 10 different systems, because each system requires different types of data formatted file structures, and that's not a very scalable and repeatable approach. So what we are seeing increasingly across the entire data world is people are demanding, the organization demanding more and more open table formats. And we are seeing the same trend coming towards the world of spatial as well. The future of spatial data is undeniably open, and that is something that we need to celebrate. Open table formats like Apache Iceberg give organizations a stable, interoperable, and future-proof foundation for for the geospatial data. Think about all of the geospatial data sets that still sit in isolated systems in shape files, in JSONs, and this format, and Tiger, and all um, inaccessible and underutilized. By adopting open formats, we unlock these assets so they can move freely across tools, industries, and clouds. This eliminates the heavy friction of conversions, hand built connectors, bespoke pipelines. More importantly, it accelerates innovation because when data becomes interoperable, new value chains start to form. Open formats only create value when the ecosystem around them is equally open. This is where PG Lake becomes a powerful bridge. PG Lake is a Postgres extension which provides native support for Iceberg alongside widely used open format, which means your data lake can speak the same language across the tools and platforms you rely on. And because Snowflake also supports Iceberg, as a first class citizen, we now get something we never had before: a seamlessly connected data layer between Snowflake and Postgres through PG Lake. And this unlocks three major advantages: interoperability without duplication. Snowflake heavily encourages zero copy sharing between various applications, and this is an extension of the Snowflake vision. Data stored in Iceberg can be accessed and processed by Snowflake, and Postgres without heavy ETL or format conversion. You can have an operational application doing front-end transactions processing, and the data could be saved at the backend in Iceberg. And the same data can then be queried by a Snowflake query for analytical purposes, doing some seasonality analysis, different kind of mapping and strategic analysis that can be applied. So bringing that strategic and tactical queries all in the same environment. Number two is the freedom of movement. Workloads can run where they make the most sense. Analytics in Snowflake, operational workloads in Postgres, all pointing to the same iceberg backed datasets without creating additional copies, no latency. The moment the transaction happens on the front end, immediately the data is available for analytics at the back end. So again, that the combination of tactical and strategic running in the same environment seamlessly without creating additional pipeline is extremely powerful. And number three, it opens up a unified open architecture. Instead of scattering data across proprietary systems, organizations get an open interoperable foundation that supports multiple engines while maintaining strong governance. PG Lake doesn't just support open formats, it connects them, enabling Snowflake and Postgres to work together on Iceberg in a way that feels natural, unified, and future proof. And that unlocks so many possibilities for organizations all over the world across all different types of industries. So, what next we are going to do is we are going to have a quick demo of how some of these capabilities come together to provide unique insights in for different users. So let's talk about this. So what I am here is I'm inside the Snowflake UI in Snowsite, and I'm going to go into the compute environment, and I'm going to spin up a Postgres instance, select the memory type, version. I can select high availability, and I can then create the environment. It will generate a connection string and the environment variables. I can copy those connection strings and environment variables and bring them those environment variables into PSQL. I can connect to PSQL, and then I can look at the various objects that are in the system, the tables and sequences that are available. I can then run a simple query. I'm looking at a simple sales table, today's sale, and I see what type of data exists in there, and I've got some timestamps and different kind of other metadata about the transaction that appears in there. Going back, I've got another table in Snowflake which has sales information, and it has some location information in the form of lat long as well. So Snowsite is giving you different information about the data. It has some histograms automatically generated as well. So now what we are going to do is we are going to expose these two tables through Streamlit. And not just we are going to generate some charts. We can visualize, of course, through a map, and we can see what is the distribution of the data on the map and where are the stores located, different kind of insights. This is fairly standard run-of-the-mill stuff that you can do with geodata. But what we really want to talk about is how can we create net new things through this talking to your geodata. In this case, what we are going to do is, okay, I'm going to ask it, give me all the stores which are west of Mississippi. So what it is going to do is take my natural language command and try to convert that at the back end into an appropriate structure. You can see the SQL code that is generates, and then it will create a map on top of the data. So now this gives end users the possibility of interacting with the data in a unique ways. I can also check for the top 10 store locations, different information. Similarly, to different tables, I can combine them, bring them into the environment, and it will run fairly smoothly It will give you that insights, and you can combine all of this data into a single dashboard and unlocks really strong, powerful capabilities for different users in the ecosystem. So what really it does is it allows the end users to interact with the data in a way that was not possible before. They are able to build net new capabilities, interact with the data, ask further defining questions instead of asking an intermediate team in the middle to ask to build custom reports for them. You now have the end users who are really the business owners who could work with the data directly without the need for complex back and forth between different teams and departments. And you can also ask questions. Hey, describe what's happening inside the map, and you can build a complete context around this conversation. And these are really powerful capabilities for the user. So this is something that unlocks different types of possibilities. So what we can do. So let's to wrap up, let's look at the future. Today we can build a powerful unified view using tools like QGIS and Felt to bridge PostGIS and Snowflake. We can connect to Streamlit, and we are already taking a huge step forward. Things that were not possible before. The future we are working towards is one where this connection is even more seamless, where the boundary between transactional and analytical fades completely. That the future vision is that it becomes truly seamless, a data pipeline where maps, models, and machine learning work in unison. Data flows continuously from the field to the cloud, which is PostGIS, to the Snowflake AI Data Cloud, with insights flowing back, which is in the form of AI models and AI insights. And this is the future we are building towards in partnership with the open source community. This is our Geo Without Boundaries vision. It's not about PostGIS or Snowflake, it's about PostGIS and Snowflake working as one. And we are excited to be part of the PostGIS community and building this future together. So I invite you, I encourage you to come and explore the Snowflake Postgres offering and leverage various type of PostGIS applications. Connect to Streamlit, use native tools such as Felt and Carto, which are cloud native. Connect to open source desktop tools such as QGIS, which have native connectors for Snowflake. So work with them, see the intelligence in action, and leverage the tools with the freedom of choice. You can use whatever tools you like, connecting to the platforms which are based on open standards and open formats, and you'll be able to build capabilities that were not possible before. My name is Fawad Qureshi, and it has been a pleasure talking to you today. Good luck in trying out all of these capabilities, and I'm sure you will enjoy them as much as I did while exploring them today. Thank you so much.